Spectrophotometry is an analytical technique that measures the amount of light absorbed by a substance at a specific wavelength, allowing for the quantification of various analytes in the solution. So the principle is we have a beam of light that passes through a sample. The sample absorbs the light at a specific wavelength depending on its chemical composition. The amount of light absorbed is directly proportional to the concentration of the analyte as described by the Beer-Lambert law. How spectrophotometry works is it has a light source that emits a broad range of wavelengths, so UV and visible light, and then the wavelength selector, also known as a monochromator, isolates the specific wavelength suited for the analyte being measured. The sample holder, or a cuvette, is the solution containing the analyte. It is placed in a transparent cuvette. Then we have the detector. This measures the amount of light transmitted through the sample, and then that's where the absorbance is calculated. For quantification, the absorbance is converted into concentration using a standard curve. Where we use spectrophotometry in the clinical lab, we use it for chemistry panels, which measures analytes such as glucose, BUN, creatinine, cholesterol, and electrolytes. We can also use it for bilirubin analysis. This is especially useful in neonatal jaundice monitoring. We can use it in hemoglobin measurement, which will help quantify the total hemoglobin in blood samples. Drug assays as well. This will determine plasma concentrations of drugs like theophylline, digoxin, and phenytoin. It can also be used in enzyme kinetics, so it measures enzyme activity by monitoring changes in absorbance during a reaction. Some advantages of spectrophotometry is it is rapid and precise quantitative analysis. It is non-destructive and cost-effective. It has a wide applicability in clinical chemistry, environmental testing, and pharmaceuticals. And it is suitable for routine automated testing. Just some things to remember for spectrophotometry is it measures light absorption to determine the concentration of substances in the solution. It is a technique in clinical chemistry providing fast, reliable, and accurate results. It is widely used for enzyme assays, metabolite measurement, and drug monitoring in clinical laboratories.